Hello, my name is Bassam Al-Kaf and I have worked in the field of IT for more than 15 years. I specialize in networking and information security and hold several certifications such as CCDB, CCNB, a routing and switching security and service provider, VCB, and ITIL V3. I have trained in IT training centers like Aptec, New Horizons, Execute Train, and Ultimate STC. It is estimated that there will be about 1.5 million unfilled jobs in cybersecurity by the year 2020. A more recent statistic increased this number for cybersecurity unfilled jobs to be 3.5 million by the year 2021. In addition, recent article highlights Cisco Systems' intention to become a cybersecurity force. For these reasons, Cisco created the CCNA CyberOps certification, which can become one of the most certifications in demand in the near future. Furthermore, Cisco created a scholarship program for this certification, which emphasizes its importance. In this course, you will learn about the tools that you can use for your study of the CCNA CyberOps certification. Learning the theory side is important, but the hands-on side is more important since the main purpose of your study is to apply your knowledge in production, and since your hands-on will enforce your theory knowledge. You cannot teach someone how to drive a car by showing him or her how to do it, but you have to let him try and practice how to do that. Furthermore, showing you hands-on labs and how to use tools without teaching you how to create these labs and install these tools might not give you the ultimate benefit from your study. For this reason, I have created this course to teach you how to create your own home labs and how to understand the core usage and important features of the tools used in them. I believe in the saying, give a man a fish and you feed him for a day, teach a man how to fish and you feed him for a lifetime. If you have access to online labs such as that offered by Cisco through their scholarship, you still need to know how to create your own home labs to continue practicing and experimenting, which is what this course will help you to achieve. On the other hand, this course will prepare you to go through these online labs quickly and with confidence, since you will be familiar with the tools used in them, and not just online labs, but any other hands-on cybersecurity ops courses like what I intend to publish in the near future. This course will teach you how to use the following tools: Security Onion, Wireshark, Kali Linux, Metasploit, Nmap, VirtualBox, and JNS3. I hope that you will join me in this course and start your cybersecurity journey. Happy learning! We need virtualization software to install and use Security Onion, Kali Linux, and Metasploit. So we will use VirtualBox for that purpose, but let us first define virtualization. So what is virtualization? It is an abstraction layer using a hypervisor, which is the virtualization software that hides the operating systems from the underlying computer hardware and runs multiple VMs or virtual machines on a host or physical machine so that they virtually share its resources. And we have two types of hypervisors. Type 1 or bare metal, which is loaded directly on the hardware, and then the VMs will be installed over that. Examples include VMware, ESXi, and Microsoft Hyper-V. And Type 2 hypervisor, which is loaded over an operating system that is running on the hardware. So here we have an additional layer, which is the host operating system. And examples of this type is VMware Workstation, VMware Fusion, which is used on Mac, and Oracle VirtualBox. And as you guess, Type 1 hypervisor is better in terms of performance, and therefore it is usually used in data centers, while Type 2 is used usually on desktops and laptops by individuals for testing and learning. And we have many types of virtualization. We have, for example, server virtualization, desktop virtualization, network virtualization such as virtual routers, switches, and firewalls, and application virtualization, and so on. And the benefits of virtualization include resources utilization or optimization, since it solves the server underutilization problem, so you can install multiple virtual servers on a single physical server instead of running one application per physical server. That leads also to reduce the number of servers used, which results in savings in cost, power, cooling, and space. And the saving of power and cooling could be done also during operation, either manually based on utilization by moving machines between physical servers using vMotion, for example, or even automatically using DRS or distributed resource scheduler and DPM or distributed power management in VMware environments. Another benefit is availability, so anything affects one VM does not affect other VMs on the same physical server. And the DR or disaster recovery will be better since it can be faster and automated. And we have also scalability, for example, virtual machines, cloning, hot additions of CPU and memory, and so on. Virtualization also makes management easier because we have fewer physical servers, centralized management, and quick deployment. So what is VirtualBox? It is a free and open source virtualization software that is developed by Oracle Corporation after acquiring Sun Microsystems. And it is Type 2 hypervisor, so it runs on a host operating system and not directly on the hardware. These host operating systems include Linux, Mac OS, Windows, Solaris, and OpenSolaris. And the guest operating systems include Windows, Linux, BSD, OS2, Solaris, and others. So in this course, we will be creating VMs, where we will be asked first for essential information such as the name of the VM, the type such as Microsoft Windows or Linux, and the version such as Windows 7 or Ubuntu. Also, we have to specify the memory size for this VM. And then the hard disk. So if we want to create a new virtual hard disk, use an existing one or not using one at all. And if we selected to create a new hard disk, then we will be asked to specify the type of that, which can be VDI, VHD, or VMDK, and if the size of the disk should be fixed or dynamically allocated. Then finally, as you guess, we have to specify the size of the disk. Then we can configure options such as networking, where we can enable network adapters and specify how they will be attached to the network. So we have the option of NAT, for example, which will allow VMs to only access the internet, the NAT network option, which adds the possibility for the VMs to communicate with each other, the internal network option, which is like the NAT network but does not allow accessing the internet, the host only option, which is like the internal network and adds the possibility to communicate with the host machine, and finally the bridged option, which allows for all types of communication. And in our case, Because we want our adapter to sniff traffic or listen for all traffic even that does not descend to the VM, we have to set the promiscuous option to allow VMs or allow all. And we can also configure other things such as display, audio, serial ports, USB, and so on. So in this lecture, I have given an introduction about virtualization and VirtualBox. And in the next lecture, I will explain how to download and install VirtualBox. In this lecture, I will explain about how to download and install VirtualBox. So, the first step in creating our lab environment is by installing virtualization software, such as any VMware flavor or Oracle VirtualBox, which I have chosen because it's free and easy to use. VirtualBox will be used to create virtual machines or VMs in the lab environment, including the Security Onion VM, the Kali Linux VM, and the Metasploit VM. So first, we will download VirtualBox by going to this link shown here, which you can find in addition to all other links for downloading the required software for this course at the first lecture. Now I will start downloading VirtualBox for Windows hosts and click Save File. We see that the downloading is starting now. So I will stop recording and continue after the download is complete. And we see now that the download is completed. So now I will launch the setup for VirtualBox and click on Next, and then also on Next, and I will leave these options selected and click on Next, and it gives us a warning about network interfaces that it will reset our network connections, and there is no problem with that, so I will click on Yes, and then Install, and we see that the installation process is now in progress. And if it is the first time you are installing VirtualBox, you might see messages about trusting software from Oracle, and you should click on Yes for these messages. So it is progressing now in the installation process. And we see that the installation is now completed. So I will click on Finish to start VirtualBox. We see now that we have installed VirtualBox successfully, and in the next lecture we will start installing and configuring the Security Onion VM. In this lecture I will introduce Security Onion to you and explain briefly how we will work with it through our lectures in this course. So, Security Onion is a distribution of Linux intended to support security analysts with a suite of tools for network security monitoring, including intrusion detection, network security monitoring, and log management. The Security Onion distribution is based on the Ubuntu Linux OS and contains several useful security tools that deals with the following data types. Alert data that indicates a possible attack or malicious activity and includes heads alerts from OSSEC and NEDS alerts from Snort or Suricata. Asset data from BRO. Full content data such as full packet captures from NetSniff NG that records all the network traffic packet by packet at specific network locations. Host data via bits, OSSEC, syslog, and more. Session data from BRO, and it is a summary data that is associated with network conversations. Transaction data that is more than session data but less than full packet captures, since it gives the details that are associated with the requests and responses. These includes HTTP, FTP, DNS, SSL, and other logs from Bro. So first, in this course, we will create the VM of Security Onion in VirtualBox and configure its settings. And then we will download the ISO image of Security Onion. Then we will install the operating system. Run the security setup to install the tools. Update the software. Install the Linux Guest editions for better integration with the host operating system and better performance. And finally, we will learn about how to take snapshots of our VM so that we can revert to them back if something wrong happened, or to revisit a previous lecture and practice again with it. And I recommend that you take a snapshot after each lecture while you follow me with your practicing. In fact, I have used that while preparing and recording this course. Then we have to analyze backup files, which you can find sample of included with Security Onion or download from the internet. And I will show both ways to you. And to import or replay those files, we can use either the TCP replay command, which changes the timestamps of the logs resulted to be of the date of running the command, or we can use the su import backup script that will preserve the original timestamps. And then we will work with security information and event management products that provides centralized log management. So first, we will learn about ELSA, which will be end of life soon, but I found it very useful to learn about how to use. And then we will upgrade to Kibana and learn about it. And for NSM or network security monitoring, we will use Sguil so that we can see alerts coming from Snort, for example, categorize those events, and pivot into other tools. And we can also use Squirt, which acts as the web-based version of Sguil. So in this lecture, I have introduced Security Onion to you and explained briefly how we will work with it through our lectures in this course. In this lecture, I will give a brief introduction about Security Onion and explain how to download its ISO image. So here in the link shown, we see a brief introduction about Security Onion that says, Security Onion is a free and open source Linux distribution for intrusion detection, enterprise security monitoring, and log management. It includes Elasticsearch, Logstash, Kibana, Snort, Suricata, Pro, OSSEC, Sguil, Squirt, Network Miner, and many other security tools. So understanding and working with Security Onion is very useful for studying the CCNA CyberOps certification and for being a security analyst. And in our lab, instead of using Elasticsearch, Logstash, and Kibana for log management, I will use ELSA, or Enterprise Log Search and Archive, which is used in the older versions of Security Onion. And by the way, the name of this tool, Kibana, just reminds me of Kitana of Mortal Kombat. But in fact, I think that ELSA also looks like a name of a princess. We see here the data types that Security Onion tools deals with. And here we see screen shots from the Security Onion, from Kibana, and other tools. And now we will go to download the Security Onion ISO image. Here we see that the current version is the 16 something version, but we will download and install an older version just in order to use ELSA. So I will go to the history, and then I will download the 14.04.5.7. So I will click on this link here, and then I will copy the link for the ISO image, which is this link, and then I will paste it here, and I will save the file. So we see that Security Onion is now being downloaded. So I will stop the recording and continue after the file is fully downloaded. So here we have downloaded the ISO image for Security Onion successfully, and in the next lecture we will configure the settings for Security Onion VM in VirtualBox. In this lecture I will explain how to create the Security Onion VM in VirtualBox and how to configure the settings for it. So to create the VM, I have to click on New, and then I will set the name of the VM to be Security Onion, and the OS should be Linux, and it should be Ubuntu because Security Onion is using the Ubuntu distribution of Linux, and it should be here 64-bit. And in order for the 64-bit option to appear in this menu, you might need to go to BIOS and enable virtualization. So I have done that before, and now I will click on Next, and then we have to set the memory or RAM for this machine, and I recommend that you set it to 4 GB, which is here 4096, and then I will click on Next. Now we have to choose how to deal with the hard disk, and we have the options either to do not add the virtual hard disk or create a new hard disk or use an existing virtual hard disk, and I will choose to create a new hard disk. Now we have these options for the hard disk file. So the first one is VDI or virtual disk image, which is the native format of VirtualBox, and the second one is the VHD or virtual hard disk, which is the native format of Microsoft Virtual PC, and finally the VMDK or virtual disk machine, which is the virtual machine hard disk that is developed by VMware, but it is supported by many virtualization software from other vendors, including VirtualBox. There is no big difference between the three here in our lab, but I will go with VMDK. So I will click on Next. Now we have these options about how to deal with the storage on the hard disk or of the hard disk, and the first option is dynamically allocated, and the second one is the fixed size option. So the dynamically allocated or dynamically expanding disk starts small and grows as needed until it reaches the maximum size you have allowed for it. So it does save disk space. However, In terms of performance, it will increase disk fragmentation, especially when writing large amount of data to your VM, which can degrade the performance of both the host and guest operating systems. And in this case, using fixed size hard disk is better. So in production environment or in lab that you have a lot of writing or a lot of processes that writes to the hard disks, you have to choose the fixed size. But here I will use the dynamically allocated option just in order to save disk space. So I will click on next. Now we have to set the size for the hard disk, and it is by default here 10 GB, but I recommend that you set it to 20 GB, and then I will click on create. So now we see that the Security Onion VM is created and it is now powered off, and I have to go to set other settings for this machine. Like on the system here, I will increase the number of CPUs to be 2 CPUs, and also on the network I will configure another adapter, and here we see the first adapter which is attached to NAT, so we can access the internet using this adapter. And we also see that the promiscuous mode is set by default here to deny, which is okay because we will not use this adapter for sniffing traffic or capture packets, but we will use the second adapter or adapter 2 for this purpose. So I will enable this adapter and I will attach it to internal network so that it can communicate with other VMs here in VirtualBox in order to sniff or capture packets from this network. And here we see that the name of the network is by default is set to internet, and here we must set the promiscuous mode to be allow VMs or allow all in order for this adapter to be able to capture traffic that is passed on this internal network. And now I will click on OK, but before that I will show you that here the configuration of the disk. We see that the disk here is the securityonion.vmdk hard disk. Now I will click on the OK. So now in this lecture we see that we have created the Security Onion VM and we have configured the settings of this VM, and in the next lecture I will start to install the Security Onion software or the OS for the Security Onion on this VM. In this lecture I will start to install the operating system for the Security Onion VM. So I will go to settings and then storage, and then we see that the optical drive here is empty, so I have to insert the Security Onion ISO image in this optical drive. So I will go to this optical drive and then choose virtual disk, and then I will select the image that I have downloaded before, and then I will click on OK here. Now I will click on start so that we will start the installation process. We see this option, install Security Onion. I will click on enter or just wait for the automatic boot. We see now that the installation process is beginning or starting. Here we see that the installation process is in progress. We see that we have to select the language here. So I will select English and then continue. And we see the recommended settings that the Security Onion VM should have at least 8.6 gigabytes available drive space, and we know that we have more than that. So now I will click on continue here. We see that we have these options of erase the disk and install security onions and the encryptions and other options, and we know that the hard disk is new, so no problem with the erasing the disk. So I will click on install now and then continue. We see the option here for setting the location, and here it's set to New York, and I will let it as it here, and then I will click on continue. Now we see the keyboard layout, and here it is English US, so I will click here on next. Now I have to set the name, so I will set the name to be my name, Bassam, and we see that it populates the name of the machines to be Bassam VirtualBox, and here the username and then the password. So I will use here a simple password just to work fast in this lab. And in production, you know that you have to set this password to be a complex or strong password in order to secure your environment. So now I will click on next. Now we see that the security onion or the installation wizard is copying files. Here we see that we have reached the state or the step of almost finished copying files. So we will move shortly to the next step. So now we see that the install process is now installing the system or starting installing the system. We see that the installation process now is configuring some settings, and it's now retrieving some files. We see here that the install wizard or process is downloading a language packs. We see now that it has completed the downloading of the language packs, and then it moves to the next steps like configuring the Chromium web browser and configuring the hardware. We see now that the installation is complete, and we need to restart the computer in order to use the new installation. So I will click on restart now. We see that the VM is restarting, and we have to click here on enter, and then also enter on this option. So we see now that the security onion VM is starting, and we see here the progress bar for this startup process. Okay, now we see that we have to enter the name, which is Bassam, and then the password that we have configured before. So then login. So we see now the desktop of the Security Union. So we have installed the operating system for the Security Union VM successfully, and here we do not see any icons for the tools that is used in Security Union, like Sguil and ELSA, and this is because we have to run the setup in order to install and use these tools, and that is what I will explain in the next lecture. In this lecture, I will explain how to install the Security Union tools using the setup wizard. But before doing that, I will go and enable the skilled mode view for a better view here, and then I will launch the setup wizard, and I have to enter my password. We see that we are being asked if we want to continue or not, and I will click on yes, continue. Then it asks us about if we want to configure the network interfaces in order for optimizing or installing these tools to work correctly. So I will click yes, configure the network interfaces. Now it is asking us about if we want to configure a management interface and which interface should we use, and I will select Ethernet 0 and then OK. And it asks us now what way we want to configure the addressing, the IP addressing for this interface, if it should be static or DHCP, and I will select the DHCP option just for make things easier, then OK. Now it is asking about configuring the monitoring or sniffing interface, and I will click on yes because this is the most important thing for the Security Union, is to sniff traffic or capture packets. So I will click on yes, and the interface that is left for this rule is the Ethernet one. So OK. Now it asks us about to confirm this and make change. So yes. So now we need to reboot the system in order for this to take effect. So I will click on yes, reboot. So now we see that the Security Union VM is restarting, and after the restart, the window for login should appear, and after we log in into the system, we will continue our setup process by installing the tools after the configuration that is done for the network interfaces. So now we see that the VM or the Security Union is starting. So now I will type my name and password. So now we have logged into Security Union, and now I will run the setup wizard again and enter my password. So continue. Now it is saying that network interfaces are have been set up already. So I will click on yes, skip network configuration. Now we have two types of setup: the stable setup and the experimental setup. So the stable setup will run the current stable version of the setup, and it will configure ELSA for the log management. And the experimental setup, it will install or configure the Elastic Stack, which combines Elasticsearch, Logstash, and Kibana. And as you know, that I have downloaded and installed the Security Onion version that supported ELSA, but not the new things, which are the Elastic Stack, because this version now that we are seeing is using the Elastic Stack as experimental, but in the new version it became stable, so the Elastic Stack will be the default thing. So I will select here stable setup, since we want to use ELSA. So I will click on OK. Now we have two modes, the evaluation mode and the production mode. And the evaluation mode is recommended for the first time users or standalone VMs, while the production mode is recommended for production deployments. And because we are running just labs, I will install the evaluation mode. And in this mode, standalone VMs means that we will run the server and the client on the same machine. So the server that have the management software such as ELSA and Sguil will be run on this machine, and also the client tools such as the sensors like the Pro, Snort, Suricata will also run on this machine. While in the production mode, you will run the server on a separate machine than the client. So now I will click OK for the evaluation mode, and it asks us about what interface to be monitored, which should be Ethernet 1. And then we have to configure username for Sguil and a password, and then we have to confirm the password. Now it asks us if we want to confirm and proceed with the change. So I will click on yes, and we see now that the Onion setup is running, and it is now stopping the NSM services, and NSM is acronym for Network Security Management. So now we see that the Security Onion setup is now complete. So I have to click on OK, and we see here the commands that can we use to check the status of the running services, like sudo sustat, sudo sustat quick, and sudo sustat redacted. So I will click here on OK, and also it tells us that we can download rules, or that the rules downloaded are in this path. Now we see that the tools have been installed, like ELSA, Sguil, and Squirt. So that means that we have run the setup wizard and installed the required tools for security onions successfully. And in the next lecture, I will explain more things about security onion, like updating the software and installing the guest editions and taking a snapshot of the system. In this lecture, I will explain how to update the Security Onion software, including both the Ubuntu OS and the Security Onion tools. So, in order to do that, I will go to open the terminal emulator and then execute the command sudo soup, which is a script that will update the software. And we have to use sudo because we are not allowed to run this script if I am a normal user, and I have to escalate my privilege to be a privilege of a root without logging in with the root account and entering the root password. So now I will click on enter, and then I will enter my password. We see now that the updates will be downloaded and installed after I click enter. Now we see that it is checking for updates, and this will take some time for checking the updates and download them and then install them. So I will stop the recording and continue after this process is complete. So we see now that the Security Onion update process has completed, and it downloaded the required packages and installed them, and actually it has taken a lot of time to be completed. So now I will press enter to reboot and finish or complete this process. So enter. You see now that the Security Onion VM is restarting, and we will log in back to the Security Onion VM, and the next step after this should be installing the Gust edition. So in the next lecture I will explain about how to install the Linux Gust edition for this machine of Security Onion. In this lecture, I will explain how to install the VirtualBox Gust editions for Linux. So after updating the software successfully, we still see the icon of ELSA on the desktop. And in fact, if you'd updated the system before running the setup, you will find that ELK or Elasticsearch, Logstash, and Kibana will be installed instead of ELSA. So in order to keep and use ELSA, I had to run the setup before updating the system. So the order of the steps does matter here. And actually, if you searched on the internet, you will find that it is recommended that you update the system before running the setup. However, this is not true in our special case because we want to use ELSA. So now I will install the Gust editions, but I have to download them first by going to the link shown here, and then I will go to this folder for this version of VirtualBox, which is 5.2.12, and then I will download the Gust editions ISO image, and then I will save the file, and here we see that the download is in progress. So now I will pause the recording in order for the download to be completed, and then I will continue the installation of the Gust editions after that. Now, after we see that the download is successfully completed, I have to install these Gust editions by going to the VirtualBox and then the settings of the machine and then storage, and then I will insert the ISO image into the optical drive, so this one. And now if we go to our virtual machine, we see that the image is inserted into the optical drive, and then or before installing the editions, I have to mount the volume here, and then I will go to open a terminal emulator and then go to this path of /media/sam and then /vbox Gust editions folder, and then I have to execute the command to install the Gust editions. So I will indicate that I want to run a file that is in the current folder, and I have to use the sudo command to escalate my privilege, because if I didn't use that, I will not be allowed to execute the command. So sudo /vbox Linux editions, and I have used the tab in order to help me to complete the full name of the file. So now I will hit enter to run the file and install the Gust editions, and I will enter now my password. So now we see that the Gust editions are being installed, and the purpose of installing these Gust editions is for a better integration between the Gust operating system or the Gust VM and the host operating system, and also for a better performance of the VM. So we see now that the installation process is in progress. So I will pause the recording and wait for the process to be completed, and I will continue after that. So we see now that the Gust editions have been installed successfully, and we have to restart or reboot the system in order for this to take effect. So I will go to this icon here and then click the restart button, and we see now that the system is restarting. So that way we have installed the Gust editions successfully, and in the next lecture I will explain how to take a snapshot for the Security Onion VM in order to revert back to it in case something wrong has happened. In this lecture I will explain how to take a snapshot of the VM so that if something wrong happened or we have misconfigured the system, we can revert back to this snapshot and continue from the point that everything was correct. So in order to do that, while the machine is running, I can take the snapshot here in VirtualBox. So I will go to the VirtualBox window here, and then I will click here on this icon of the camera of the snapshots. So then I will click on take. Then I have to name the snapshot, so I will name it as Security Onion Snapshot 1, and I can add some more information like ready to use, and also here on the description I can enter more information like updated, and then also just editions installed, also with setup, and also I can add the date, so 26 of June 2018, and then I will click OK. So now we see that VirtualBox is taking the snapshot for the VM, and we see here that our snapshot was taken successfully. Now in the next lecture I start to explain how to use Security Onion tools, and in particular I will start with explaining how to use the TCP replay command in order to replay some backup packets in order to simulate traffic in our network. In this lecture I will explain how to use the TCP replay command to replay backup files in order to simulate network traffic that will be captured. So TCP replay is a suite of free open source utilities for editing and replaying previously captured network traffic, and it is originally designed to replay malicious traffic patterns to intrusion detection and prevention systems. So now I will open a terminal emulator and go to this path /opt/samples, and then if I list the files in this folder, we see a lot of backup files that can we use as samples with the TCP replay command in order to simulate network traffic, or particularly malicious network traffic. And also we have other samples in the subfolders like the Markovo, MTA, and other subfolders. Now I have to run this command with the root privilege, so sudo. Then I will run all the backup files in this folder using the star.backup, and I have to use the command, so TCP replay, and then I have to choose which interface I will replay the traffic into, so I will use the I option, then the Ethernet 1 interface, and I also might have to specify the speed that I will run the or simulate the network traffic to use using the capital M option, and I have specified the speed to be 100 megabytes, and also I can use the P option in order to specify the number of packets that I will use. So now I will execute the TCP replay command, and I will hit enter. and I will enter my password. We see now that the packets are being replayed. So now we see that the number of the attempt packets is about 55,000 packets, and the successful packets, or the number of the successful packets, is less than that slightly. So, and this is the number of the failed packets. So now this means that we have successfully executed the TCP replay command. And in the next lecture, I will show to you how to download more samples of these backup files in order to simulate other attacks or malicious traffic that you might need to analyze. And also after that, we will explain how to use ELSA and Sguil to analyze this network traffic. In this lecture, I will explain how to download more samples of the backup files that you can use to practice analyzing attacks and malicious traffic. So I will open a new page of the Chromium web browser, and then I will use this link shown here, and in the page shown here you will find many links of the sites that contains backup files that you can download and then analyze. For example, this site, malware traffic analysis.net, and here we find links for the years. So I will choose this year 2018, and then I will try to go, for example, to this first link, and then I will download this backup file for this attack or malicious file. So I will click here. We see now that the file is being downloaded, and we see that the format of the file is in zip. So it is a zip file that we will need to extract to be able to analyze the backup file. So now I will click on show in folder, and we see the zip file. So now I will extract it. So extract here, and we see that there is a password required for extracting the file, which is infected, that you will find in the about page of the site that we have downloaded the file from. So I will click on OK. We see now that the backup file is extracted. So let us now open a terminal window and run the TCP replay command with the file we have just downloaded. So I will open a terminal emulator window, and then I will use the command cd downloads, and then in this folder I will run the command sudo TCP replay, and then I will specify the interface to be Ethernet 1 and the speed to be 100 megabit per second, and then I will specify the file to be the file that I have downloaded, so 2018, and then I will hit enter. Now I will enter my password. We see now that the command was executed successfully. So in this lecture we have downloaded more samples of the backup files that we use the TCP replay command through. And in the next lecture, I will start explaining about how to use ELSA. In this lecture, I will give a brief introduction about ELSA. So what is ELSA? ELSA, or Enterprise Log Search and Archive, is a centralized syslog framework that is built on syslog ng, MySQL, and Sphinx full-text search that provides a fully asynchronous web-based query interface that normalizes logs and makes searching billions of them for arbitrary strings as easy as searching the web. It includes tools to assign permissions for viewing the logs and email-based alerts, scheduled queries, and graphing. ELSA is an SIEM product, and SIEM, or Security Information and Event Management, is the glue for various security tools. It can provide information in both real-time alerts and historical reports that summarize the security status over time, typically on the order of months rather than days. The main SIEM functions include log collection of event records from sources throughout the organization, log normalization to map log messages from different systems to a common data model, logs correlation to speed the detection of and reaction to security threats, log aggregation to reduce the volume of event data to be analyzed, and finally, reporting tools to address regulation compliance reporting requirements. So ELSA is an open-source centralized syslog compiler and search querying tool. It provides many of the functions that are typically found within most of the commercially available SIEM products. Examples of those products are Splunk, Enterprise Security, IBM Security QRadar, Logarithm, and SolarWinds Log and Event Manager. When working with ELSA, you can accomplish the same task using multiple ways, which I will explain how to do in the following lectures. ELSA, as an SIEM, provides log normalization, which is the process of manipulating security event data and fitting into common schema. ELSA has parsers that work with each of the data sources. Examples of those data sources are PRO, which is an intrusion detection system program that is different from the typical IDS, Snort, which is the most widely deployed intrusion detection and prevention system technology worldwide, Suricata, which is an open-source next-generation intrusion detection and prevention engine, and OSSEC, which is a host-based intrusion detection system. In the first part of how to work with ELSA, we will see how to get logs from PRO about network connections. Log summarization is a data mining technique in which compact descriptions of key data set qualities are produced. Summarized data is often displayed in a graphical format or in tabular format. Summarization is implemented with ELSA queries by using the group by directive or clause, which can be based on source or destination IP addresses or ports, for example. Log summarization allows us to find the most interesting or suspicious traffic. For example, the traffic from the most active host. In the second part of how to work with ELSA, we will see how to get summary report based on the source IP address. This can be done in the query field by clicking on certain links or by using certain drop-down menus. Log aggregation is a data mining technique where data is gathered to get more information about particular variables. Aggregation can be performed by pooling all records that share a single common variable. For example, ELSA may be queried with simply an IP address. Log aggregation allows us to focus our analysis on the records of the most interesting or suspicious traffic found using log summarization. In the third part of how to work with ELSA, we will see how to get the records of a specific source IP address. Again, this can be done in the query field by clicking on certain links or by using certain drop-down menus. So in this lecture, I have given you a brief introduction about ELSA, and in the next lecture, I will start explaining how to work with ELSA in practice. In this lecture, I will start explaining about ELSA. So, ELSA, or Enterprise Log Search and Archive, is a three-tier log receiver, archiver, indexer, and web-fronted for incoming syslog. It can be accessed in Security Onion from the Chromium browser, which it works best with. So here I will click on the icon of ELSA, and we see this message that is saying that our connection is not private or not secure, and I have to click on Advanced and then proceed to localhost, and it asks us for a username and a password, which is the same username and password used with Sguil, since ELSA authenticates against the Sguil database. So here we see the web interface of ELSA, and the first thing we have to focus on is the from and to fields, which specify the time range that ELSA will search for the logs for, and it is for the last 2 days by default. So here I will change the from date to be this date, for example, so that it will search for logs resulted from running the TCP replay command that we have used in the previous lectures. And also, I have to specify a class here, and I will specify the class to be pro connection, so that I will search for logs coming from pro, which is an intrusion detection system program. And now I will hit enter or click on submit query. So we see here that we have more than 1000 records, and the first 100 records are shown by default. And we see also that the results are displayed in 7 pages, where we have 15 records per page, and we can change that if we want. And also we see highlighted in yellow that the records or logs are coming from the program and class pro connection, and also we see information like the source IP, source port, and destination IP and destination port, and also the connection duration, the number of bytes, number of packets, and also the country, which is here the US, so the country that the IP belongs to. So we see the country here is US, and here we see also that we have a record that the country is Russia. So we can also get the same result by using another way. So here I will close this tab, and I will remove the class from the query field, and I will go to the add term drop down menu, and I will select pro connection and then class pro connection, and we see that it populates the class in the query field. And then I will hit submit query or hit enter. So we see that we have gotten the same results here. So that way I have explained how to start using ELSA and how to specify a class and a time range to get the logs that we are searching for. And in the next lecture I will continue explaining about ELSA and specifically about how to use the group by clause. In this lecture I will continue explaining how to work with ELSA using more options, particularly displaying the summary statistics using the group by clause or keyword. So here in ELSA we see the field summary about the results that we have gotten, where we have, for example, one program, one class, 9 source IP addresses, 85 source ports, and so on. And if we want to display the 9 source addresses that are present in these records, I will click here, and we see that a new tab appeared with 57 IP addresses with the number of records for each source IP. And you might ask, but we should have 9 source IP addresses, not 57. And the answer to this question is that the 9 source IP addresses are for the first 100 records, while the 57 source IP addresses are for the whole 1000 plus records. And to be sure of that, I will go to the first tab and then insert or change the limit for the number of the records to be 1500, and then I will hit on enter, and we see that a new tab appeared with the source IP addresses to be 57. And also in the first tab we see that when we clicked on the source IP link, that in the second tab the query field was populated automatically with the group by keyword based on the source IP address. So this is another way for displaying the summary statistics by using the group by keyword in the query field. Also, there is a third way to displaying these summary statistics, which is by using the report on drop down menu. So here, if I go to the first tab and then select report on and then pro connection and then source IP, we see that the group by keyword based on pro connection source IP was added to the query field, and then I will hit here on enter, and we see that a new tab was appeared with the same results as the previous tab. And also we have another or fourth way or a final way for displaying the summary statistics, which is by using the connections originators top link. And to do that I will close all the opened tabs, and then I will click on this link here. So the connections top originators link, and I will click now, and we see that we do not have any results because when we did that, the date just changed back to be the date for the last 2 days. So I have to click on the from and then select the date to be this date, and also I will again change the limit to be 1500, and I will hit on enter again, and we see that we have the same results based on the source IP. So also we see that the summary statistics displayed the number of records for each IP, starting with the most active one, or the IP that has the highest number of records, so the most active one, and we can rearrange the order by clicking here on the count field, and also by arranging the IP addresses based on the number of records. So starting with the most active one, we can focus our analysis on the traffic that is more suspicious in order to eliminate the false positives as much as we can. So in this lecture, I have explained how to work with the group by clause or keyword in ELSA, and in the next lecture I will explain how to filter the results more based on a specific value. In this lecture, I will continue explaining how to work with ELSA by filtering the results based on a specific value. So here, after getting the summary based on the source IP address, if I want to get the records of a specific IP address, I can click on the link for that IP, for example, the second one here. So now we see the records about this IP only, and we can focus our analysis more about that one. Another way for doing that is just by typing manually the value of that IP in the query field, as we see here, which was done automatically when we have clicked on the summary link. A third way for searching for the records of a specific entry is by using the add term drop down menu. So here in the query field, I will remove the group by keyword, and then from the add term drop down menu, I will select procon and then field source IP, and then I will type the IP that I want to search for the record of it, so 10.100, and then I will click on add, and we see that the procon.source IP was added to the query field for that IP, and then I will hit on enter here, and we see that we have gotten the same results as we have for the previous tab. And a final way for doing that is by clicking on the link of the entry that we want to search for in the record itself. So here in the first tab, I will set the limit to be 1500, and I will remove the group by keyword, and then I will change the from date to be this date, and then I will hit enter, and I will search for the specific IP, and I will find it on the 9th page. So we see this IP here. So I will click on the link of that IP, and then in the query field I will hit enter, and we see that again the bro connection.source IP for that IP was added to the query field. So now I will hit on enter, and we see that also we have gotten the same results. So now if we want to focus more on a specific record, we can click on the info link for that record, for example this one, and then select get bcap and enter our credentials, so the username and the password, and click on submit. And here we see the details about this record, for example the operating system used, and also the transactions done between the client, which is presented in blue, and the server, which is presented in red. So in this lecture I have explained how to focus the analysis more based on a specific entry, and how to display the details of a specific record using the getBcap or capme. And in the next lecture I will start explaining how to use Sguil. In this lecture I will give a brief introduction about Sguil and Squirt. So Sguil is an intuitive GUI that provides access to real-time events, session data, and raw packet captures. It gives information about the following data types: NITS alerts from Snort or Suricata, HITS alerts from OSSEC, asset data and session data from BRADS, and HTTP logs from BRO. You can pivot from Sguil to other tools and websites for more analysis. For example, transcript, where an ASCII decode of the raw packet data will be displayed. Wireshark, where the raw packet capture file will be opened for analysis in this well-known packet analysis tool. Network Miner, which provides a tab-based report of the host IP addresses, DNS transactions, files, images, credentials, and other artifacts within the bcap. Pro, that performs ASCII decode and more, such as decoding HTTP traffic. VirusTotal, which aggregates many antivirus products and online scan engines to check for viruses that the users on antivirus may have missed, or to verify against any false positives. Kibana or ELSA, which are SIEMs or security information and event management applications, and many other tools and websites. Sguil is efficient since it allows you to classify or categorize events quickly, or escalate them to be analyzed by a senior analyst if necessary. It can also display alerts in real time, and the events in Sguil can be categorized into 7 categories: unauthorized root access, unauthorized user access, attempt unauthorized access, successful denial of service attack, poor security practice or policy violation, reconnaissance, probes or scans, and virus infections. And we can escalate the events as we have said, or classify them as NA or no further action is needed if we think that they are false positives. And we can add comments while categorizing events, so it can help our colleagues and save their time in future when working on events. And finally, you can perform AutoCAT to classify specific traffic automatically for a specified period of time, rather than doing that manually. And we have another tool that shares the same database with Sguil, but provides different interface, which is Squirt. So Squirt is a web application that is used to query and view event data stored in Sguil database. And we can perform typically the same things as in Sguil, such as grouping and ungrouping of events, pivoting into other tools and websites, and categorizing events. So in this lecture, I have given a brief introduction about Sguil and Squirt, and in the next lecture, I will start explaining about how to use Sguil. In this lecture, I will start explaining about how to use Sguil. So I will click here on the icon of Sguil, and we see that we are being asked for our credentials. And then we are being asked for the interfaces to be monitored, and I will select the Ethernet 1 interface to be monitored with Snort, and then I will click on Start Sguil. And here we see the alerts coming from Sguil, and we see columns like the ST or status of alert column, and we see here the word of RT, which means real time, and we see here that we have alerts with the colors of red or orange, so these is the status of the alert. And also we see columns like the count, so the number of related alerts, and also we see the sensor, which is here Ethernet 1, which means Snort, and we can check for that if we click on the agent status. And here we see that Snort is the Ethernet 1, and also we see that the alerts has all started with the number of 3, which means Snort. And also we see columns like the date and time, the alert ID, and source and destination IP addresses and ports. And if we click on this group of alerts and then click on show packet data, we can see the data contained on the packets of these alerts. So here we see the IP addresses, TCP, and the data. And if we click on the show rule, we see the rule of Snort that triggered this group of alerts, and here we see that it is a policy BEXE or DLL Windows file download HTTP. And for the second group of alerts, we see that it is a possible Trojan, and we can guess that these two groups of events are related since they have the same count number and also the same timestamp and the same socket information, so the same source IP addresses and destination IP addresses, source and destination ports. And if we want to show those group of related alerts, we can click on the count column here and select view correlated events, and here we see that the alerts are being ungrouped. So we are seeing now the related or those related events, the 24 events. So Snort or Sguil grouped those events since they are related. So in this lecture, I have started explaining about Sguil by exploring its interface, and in the next lecture, I will continue that explanation, specifically about how to pivot from Sguil into other tools. In this lecture, I will explain about how to pivot from Sguil into other tools. So first I will close this tab, and we see here that we have so many alerts. So if we want to focus our analysis on a specific alert or a specific group of alerts, we can pivot into other tools by right clicking into the alert ID and then choose a tool. So for example, network miner, and here we see information about the hosts, files including malicious ones if any, images, messages, credentials, sessions, DNS, and other information. And we can pivot into Wireshark, for example. Where we can analyze the packet in detail. So for example, we can extract possibly malicious files there that were transferred, analyze them ourselves, or submit them to be analyzed on sites such as VirusTotal. And we will explain more about Wireshark in the next lectures. And we can get more info about a specific IP address. For example, we can make a query from the query menu and then query by IP, and then let us select this IP 195.2.253.92, and then click on build, and then I have to change the date to include alerts or events that this IP is involved in. So then I will click on submit. And here we see that we have about 48 records about this IP. So I will close that tab. And we can also pivot about the IP into other tools. So let us try and pivot into ELSA, for example. So I will right click on this IP and then choose ELSA, look up and search for that IP as a source. So now we see that we have to enter our credentials into ELSA to log in. And we didn't get any results because of the date, so I will change the date once more time and then hit enter. So here we see the info about that IP in ELSA grouped by the program like snort, pro connection, profiles, and pro HTTP. Let us try and pivot into another tool, for example VirusTotal, but let us try with another IP. So let us try with this one. So I will right click on it and then select VirusTotal and then source IP, and here we see information about that IP like the country, the domain names, the detected malicious URLs, and how many antiviruses detected that as malicious. So for example, this one is detected by 3 out of 64, and below that we find detected malicious files that were downloaded from that IP and their hashes, and also undetected malicious downloaded files, detected and undetected files that communicated with that IP. And here we see the dates that there was a malicious activity associated with that IP. So it might not be malicious now. And because we have used TCP replay command with bbcap files, our timestamps were of the date we ran the command. But if you want to get timestamps in ELSA, Sguil, and Squirt with the dates that those bcaps files were originally created, we have to use the so import script. And in that case, we will get timestamps close to those shown here in VirusTotal. And in fact, if this was a live attack in production, then it is recommended to use internal analysis method instead of an external one, because attackers could know about that we are tracking them. And also, we can pivot about the source port and destination port. So in this lecture, I have explained about how to pivot from Sguil into other tools. And in the next lecture, I will explain about how to categorize events in Sguil. In this lecture, I will explain about how to categorize events in Sguil. So, as we have noticed that the first two groups of events are likely virus infections. So, it will be useful if we can categorize events and view events for each category. So, for example, I clicked on the query menu and then query by category and then select virus infection category or category 7, and then I have to change the date to include the events that the alerts were generated, and then I will click on submit. We see that we do not have any results, and this is because we have not categorized events yet. So we have to do that beforehand. So I will close the query builder and I will right click on the event and then I will choose update event status, and then I will choose the category 7 or virus infection category, and we see that the event disappeared from the queue here because it is moved to category 7. Now if we repeated the query again, so query by category and then virus infection or category 7, and then I have to change the date and then click on submit. Now we see that we have those 24 rows that we have categorized them to be in category 7, and we can execute the query also by right clicking on the alert and then select advanced query and then the category that we are searching for, and we see that the same window of the query builder was opened. So then we can change the date and then click on submit to get the same results. Another way is by right clicking on the alert and then choose quick query and then virus infection, and here we see that we have gotten 0 rows because the date, so we have to click on edit, and then we see also that we have gotten the same query builder window, so we will change the date and then get the same results. And you can categorize events quickly by using the F keys. So you might notice that the virus infection category has an F7 key here. Therefore, if I click on an event, for example, this one, and then I can assign it to virus infection category by pressing the F7 key. So we see that the event disappeared now from the queue because it has been assigned to its new category of virus infection. And here below we see other exe or DLL Windows file download events, which are those ones, and I can categorize those, but I will rather do that in Squirt. Also, in addition to set the event category, we can escalate the event. So events will appear under the escalated events tab to be reviewed and analyzed by a higher level security analyst who can assign them to a specific category if needed, or might determine that it was a false positive, for example. So for example, I will escalate those 12 events. So I will right click on them and then select escalate, and then I can type, for example, exe download as a comment, and we see that the events disappeared from the queue and we can find them under the escalated events tab. And also we can add a comment for an event by right clicking on the event and then update event status and maybe add a comment that is belonging to a specific category. And sometimes you might find it useful to do this categorization automatically for repeated events, especially those you think they are false positives, which will save your time and allows you to focus on the more suspicious events. So for example, if I right clicked on this event and then select create AutoCat from event, and then I can set a period for that auto categorization. So let us set that as 3 hours, and then I have to set the category, which is by default category 1 or the NA category, and the other 7 categories have the numbers from 11 to 17. So I will click on submit here. So in this lecture I have explained about how to categorize events in Sguil, and in the next lecture we will explore Squirt. In this lecture I will explore Squirt, which is a graphical web interface on top of Sguil. So I will click on the icon of Squirt, and we see that we are being asked for our credentials, and you might see a message before that saying that the connection is not private or not secure. So we have to click on advanced and then proceed, as we have done with ELSA, and that is okay here in our lab environment, but in production you have to set your trusted certificate authority. So now I will click on submit, and the first thing we have to set here in Squirt is to change the date of the alerts, because by default the alerts are displayed for the last date. So I will click on this link here, and from Sguil we see that the date of our alerts is the 26th of June. So in Squirt I will select the month to be June, and then the date to be this date, and we see now that the alerts are displayed, and we see the priority percentages and numbers for the alerts, and we can focus on a specific priority, for example the high priority events or alerts, by clicking on this link. And we want to find the alerts that we have classified before in Sguil as category 7 or virus infections. We can find those under the malicious category. So we have here 48 alerts that we have classified before in Sguil as virus infections. So I will click on this link, and here we see those alerts. So we have two groups of 24 alerts. The first group is the ET Trojan, and the second group is the ET Policy BEXE. So let us click on this one and click one more time, and here we see these events that were classified as category 7. And now I will clear the filter of this category. And now if we want to find the events that we have not classified as category 7 in Sguil, but we should do that now in Squirt, we see those 48 events as not classified out of 72 alerts with the ET Policy BEXE signature. So 24 of those are classified as malware, but 48 are not. So I will click on those now, and we can classify, for example, these first 12 of them. So I will click here, and we can classify or categorize an individual events by checking on one of them, or we can classify all of them. So I will classify all of the alerts, and then I will press on F7. So now we see that these alerts are classified now as category 7 or virus infections, and we see that the number of the malicious category is increased to be 60 instead of 48. And we can see the events that we have escalated before in Sguil by clicking on this link. So we have 12 events or alerts. So we see this alerts that we have escalated before in Sguil. And as we have seen with Sguil, we can pivot into other tools by clicking on the alert ID, and then pivot into other tools, specifically the CABME tool that views backup files, and that we have seen before when working with ELSA. So now we see these CABME, and here in this tool we can also download the backup file and analyze it using other tools such as Wireshark, for example. We can also pivot about a specific IP address, as we have done in Sguil, by clicking on it, and we can search for that IP here on Squirt, as a source or destination, for example, or we can pivot, for example, into other tools such as domain tools, ELSA, Google, malware domain list, safe browsing, virus total, and other tools. And we can pivot also about ports into other tools or here. And in Squirt we can also group and ungroup events. So here if I clear the filter and then go here and click on this link, so events are by default grouped in Squirt, but I can disable grouping. So if I click on that one or this link and then click on refresh, we see that the alerts are now ungrouped, and I can group them again if I want. So in this lecture we have explored Squirt, and in the next lecture I will explain about the so import script. In this lecture I will give a brief introduction about Kibana and Elastic Stack. So what is Elastic Stack? It is a collection of free and open source projects that is developed by the Elastic company. It allows you to centralize the monitoring, alerting, and logging for your server and application infrastructure, so you can track hundreds or even thousands of servers. It was originally named ELSA as an acronym for Elasticsearch, Logstash, and Kibana. It was renamed to Elastic Stack after adding the bits utilities. The first component of the Elastic Stack is Elasticsearch, which represents the back end of the Elastic Stack. It is a search and analytics engine that allows for fast, full-text searching using a distributed, highly scalable indexing and document database. And then we have Logstash, which is a server-side data processing pipeline that ingests data from multiple sources simultaneously, transforms it, and then sends it to Elasticsearch. So it avoids log data inconsistency by cleaning and reformatting it before forwarding it to Elasticsearch. And also we have Kibana, which allows users to visualize data with charts and graphs in Elasticsearch. It is a powerful web-based front end that works very easily with Elasticsearch. In Kibana, it is easy to create useful dashboards and share them with coworkers. In Security Union, we can use Kibana as an SIEM instead of ELSA, since ELSA will be end of life on the 9th of October 2018. We can do things in Kibana such as log normalization, log summarization, log aggregation, and reporting. So in this lecture, I have given a brief introduction about Kibana and Elastic Stack. In this lecture, I will explain about the so import bcap script. So as we have seen when we use the tcp reply command, that the timestamps of the events replayed or imported were those of the date of executing the command, not the date when the bcap files were originally created. So in order to preserve the original timestamps of these files, we have to use the so import bcap script. But this script is included with the Elastic Stack, so we have to upgrade to that from ELSA. And we can rerun the setup for that purpose. However, a better but longer way is to use the following commands. So first, we have to use the sudo sup command to install updates, and then install and configure Elastic using the following commands. So now I have completed the upgrade process, and here we see that Kibana was installed. However, the Elastic Stack demands a memory of 8 GB at least, so I have increased the memory to this value while the VM is powered off. In addition, you might still get into memory issues, so that logstash will fail to start. So let us open a terminal window and check for that using the command sudo su elastic status. And we see that logstash failed to start. And in order to solve this issue, I will modify the heap size by editing the fabbing file. So sudo vi etc logstash jvm options, and we have to change the minimum and maximum heap size to be 4 gigabytes, for example. So I will change this value to be 4096, and this one also, and then I will save and quit. Now I will restart logstash. So sudo su logstash start, and this might take some time to be completed. So let us check again. We see now that logstash was started, and although we can execute the su import pcap script without the need for logstash to be running, we need that because we want to see the logs resulted in Kibana later. And I have already downloaded and extracted the file that we will use with the script. So this is the file that I have downloaded, and this is the extracted file. So now in the terminal window, I will use the command sudo import pcap downloads, and then the name of the file, and then I will click on enter. So now we see that the script is working, and now we see that the script was completed. So now if I opened Squirt and entered my credentials, so now we do not see any alerts that belongs to our current day. But if we changed the date to be the date of the pickup file, so we see now the alerts because that was the date of creating the pickup file originally. So in this lecture I have explained using the su import pcap script, and in the next lecture we will explore Kibana. In this lecture we will explore Kibana that will be used as our new SIEM instead of ELSA, and we will see alerts resulted from running the su import pcap script that we have executed in the previous lecture. So now if I clicked on the icon of Kibana and entered my credentials, so now we see the logs of our day, and we do not have any needs alerts. But if we changed the date to be the date of the pickup file, we have run the su import pcap script through. So this date and then I will set the to date to be the next day, so next date, and then I will click on go. So now we see that we have about 130 NIDS alerts in this date, and we see a pie chart of the alert summary, and also we see chart of alert severity and alert classification, and also we see counts of the alerts and source IP addresses and ports, destination IP addresses and ports. So this is log summarization, and also we see detailed view of the alerts, and we can do log aggregation by clicking the link of a specific value, for example an IP, and then we have to change the date to get the alerts related to that IP. So this is log aggregation. So in this lecture we have explored Kibana and have concluded our lectures about Security Onion. In this lecture I will give a brief introduction about GNS3. So GNS3, or Graphical Network Simulator, is a software solution that allows you to design complex network topologies and emulate Cisco and other vendors' devices. It is free and open source software that is used mainly to study for certifications such as CCNA, CCNB, or even CCIE. And it can be used to test network designs and configurations. So, the first decision we have to make after installing GNS3 is to select how we will run it using the setup wizard. Running GNS3 on the local server will allow you to configure basic Cisco topologies. But if you want to configure more advanced topologies, such as ones that include Cisco ASA firewalls, IOU L2, which is a layer 2 iOS on Unix, and other options, you need to use the GNS3 VM, which is a VM that is free to download. And you can run everything on a remote server that can be shared with multiple users. After that, we have the option to use a template appliance file, which is a pre-configured template that you can download from the GNS3 website to make the import process of the appliance very simple. You have to know though that the template does not include the appliance image, so you have to get that separately. Or we can manually select and configure the device type, including iOS devices, IOU devices, and other types. So we will select the manual configuration of an iOS device that requires that you have gotten the respected iOS already by downloading it or copying it from a router. And GNS3 does not support all iOS images, so you have to search to find if the iOS you intend to use is supported or not. And to emulate switches, we have choices such as using the built-in switch that have very basic switching capabilities. So it just provides connectivity and VLAN trunking with a simple GUI but no CLI. But in our case, because we have to deal with more advanced options and demonstrate attacks on switching features that we can show using CLI commands, we have to use more advanced option such as the Ether switch module, which is a 16 ports module that can be inserted into a slot of some routers such as the 2600, 3600 and 3700 series routers. Another option is using the Cisco IOS VL2, which is the best or the recommended way for using switching in GNS3. We can also use IOU L2, which is also a good option. And both IOS VL2 and IOU L2 require using the GNS3 VM. And you can insert different types of network modules into slots that you can change later from the preferences, or after dragging a device into the workspace and edit or configure its settings. And you can edit other things also, including the RAM, iOS image, and idle PC value, and so on. And setting the idle PC value will get your computer into sleep every few milliseconds so that CPU consumption is reduced. So in this lecture, I have given a brief introduction about GNS3, and in the next lecture, we will start our hands-on practice with GNS3 by downloading and installing it. In this lecture, I will explain how to download and install GNS3 so that we can use network devices in our lab. So we have to go to the link shown here, and in order to download GNS3 we have to sign in, and I have already done that. So if you don't have an account, you have to create one and then sign in. So now I will click on download, and then download for Windows, and then save file, and we see that the download is just started. So I will stop recording and continue after the download is finished. So now we see that the download is finished. So I will click on this file to start the installation process, and then I will click on run and then on next, and I have to agree to the license agreement. So I will click on I agree, and then I will click on next, and here are the components that will be installed with GNS3. So here we have GNS3 itself, and then we have WinBcap, and this is the Windows version of LibBcap, which includes a driver for capturing network traffic so you can sniff traffic in promiscuous mode, and that is necessary for programs such as Wireshark to work. And we have Wireshark, which is a packet traffic analyzer that we will explain about in detail in its own module. And in GNS3 you can use Wireshark to see the details of network traffic that moves between devices. And then we have Dynamaps, which is the emulation engine for GNS3. So GNS3 will not work without that. Chemo is a free and open source emulator that adds additional capabilities to GNS3. And in order to simulate traffic to and from PCs in a simple way, we have here VPCS, or Virtual PC Simulator. And here is SolarWinds that you can use to analyze the performance of the network. So I will select the components that are necessary for GNS3 to work. So I will uncheck Wireshark because I will explain how to install that when we come to explaining about Wireshark, and I will check all these options. So now I will click on next, and then I will click on install, and here we see that GNS3 is being installed. Now I will click on next, and here it asks us if we want to get our free license of SolarWinds standard toolset, which has a value of about $200. So I can click on yes for that, but for now I will click on no, and then I will click on next, and then I will click on start GNS3. So here we see that GNS3 is installed successfully, and in the next lecture we will go through the setup wizard in order to prepare using GNS3 for our labs. In this lecture I will explain about preparing GNS3 for our labs using the setup wizard. But before that, you might need to check if GNS3, Dynamaps and other components are allowed by your antivirus and Windows firewall, and if not, you have to allow them, and in my case they were allowed already. So here we have three options where we will select the second one in our case because it is the simplest one in terms of configuration and is sufficient for our labs initially. So I will click on next, and I have to ensure that the host binding is set to the local host IP of 127.0.0.1. So I will click on next. So we see that the connection to the local server is successful. So I will click on next and then finish. And we have the option to import an appliance template file, but that requires using the GNS3 VM, which we selected not to use. Or we can add devices such as iOS routers, IOU devices, Chemo, VM, and other types. So I will select the first option, which is enough here since we need routers and switches in our labs to demonstrate attacks on them. And you can come later and add another device type if you need that, especially after switching to use the GNS3 VM if you decided to. And then we have to select the iOS image, which is either an existing one that you have used or imported before, like I have done, or a new one that you will browse for. So I will click on next. So it detected the name and the platform, and we have here the option to install an Ether switch module. So this router will be an Ether switch router or a layer 3 switch that we can use to emulate a real switch with its most advanced features, or at least the ones that we will need in our labs. So I will click on next, and then we have to set the RAM, and I need to change that to be 256 megabytes, and you can use this link to check for the minimum RAM requirement. So I will click on next, and here we see the slots that we can choose the network adapters to be inserted in, and we can see that 16 ports Ether switch module is already inserted in slot number 1, and you can add an additional one if you need more ports, or add a different module if you want. So now I will click on next, and then we can insert WIC or WAN interface cards, and we do not need these ones currently, so I will click on next. After that, we have to find a suitable idle PC value to decrease CPU utilization, and each iOS has its own unique value of that. So we see that GNS3 found one here. So now I will click on finish. So in this lecture, we have seen how to run the setup wizard to configure a router or a switch, or specifically an ether switch router that we can use in our lab to connect VMs to and demonstrate attacks on. And in the next lecture, I will explain how to import the Security Union VM into JNS3 and connect it to that ether switch router. In this lecture, I will explain how to import the Security Union VM into JNS3 and connect it to the ether switch router. So first, I will confirm the configuration we have done for the ether switch router in the previous lecture, and then I will create a new project and call it CyberOps lab and click on OK. And let us first explore the devices in the left pane. So here we see the installed appliances, and I can view the available appliances as we see here. But let us focus on the installed appliances, and here we see that we do not have any routers installed. And here we see the switches installed, including the built-in ones and the ether switch router that we have configured in the previous lecture. And here we see the end devices, including the VPCS, and we have security devices, a combination of all devices, and finally links. So now I will drag the ether switch router into the workspace and I will start it, and then I will import the Security Union VM. So I will go to the edit menu and then select preferences and then VirtualBox VMs and click on new, and we see that it detected the Security Union VM. So I will click on finish and then OK. Now I will drag the VM into the workspace, and I have to prepare its network card. So I will right click on the VM and select configure and then network, and I will increase the network card numbers to be 2 in order to use the second card, which is Ethernet 1, which is our sniffing adapter on the Security Union VM. So now I will click on OK. Now I will start the VM. So now in JNS3 I will connect the VM to an interface of the ether switch module. So the fast Ethernet 1/0, for example, but not the fast Ethernet 0/0 interface, which is not an interface in the ether switch module. And we can see the interface labels by clicking here. Now I will run a connectivity test. So I will create a new VPCS and I will start this VPCS and connect it to the ether switch module. Now I will click on the console of that one, and then I will configure an IP address. So for example, the 192.168.1.1/24. So now in the Security Union VM, I will configure an IP address for the Ethernet 1 interface. So sudo if config Ethernet 1 192.168.1.2 with the net mask of /24, and let us check for that configuration. see that we have an IP address configured. So let us ping the 192.168.1.1 IP address of the VPCS, and we see that we do not have any replies, and this is because the no ARP configuration on the interface. So I will configure the interface with ARP. So now let us check again. We see that we are running with the ARP, so we have the no ARP keyword disappeared. So let us ping again. So now we see that the pings are successful and we have connectivity. Please note though that setting an IP address on the sniffing Ethernet card is not required, but we have done that here to demonstrate that we have connectivity through the switch. And in GNS3 we can go to the switch and use the command show IP interface brief, and we see that the interface connected to the Security Onion VM and the VPCS are up, and we can use also the command show MAC address table, and we see that we have MAC addresses on the respected interfaces. So in this lecture I have explained how to import the Security Onion VM into GNS3 and how to integrate it into the network. In this lecture I will give a brief introduction about Wireshark. So Wireshark is a network packet analyzer that displays the details of captured network traffic. It is an open source and free software that is considered the de facto standard across many commercial and non-profit enterprises, government agencies, and educational institutions. And since Wireshark is an open source application, you can develop protocol dissectors for unsupported protocol, for example, and add it to Wireshark. It is used by IT professionals, especially in the network and security fields, for baselining, performance troubleshooting, and security analysis, which is the main purpose for using Wireshark as a tool in the CyberOps field. It was named as Ethereal originally, but then renamed to Wireshark in 2006. To capture and analyze traffic that is not destined to your machine using Wireshark, the network interface card must work in the Prometheus mode. And you can install Wireshark on the PC or the server that you want to troubleshoot, or replicate the traffic to another machine where Wireshark is installed using a network tab, a hub that floats all network traffic, or use port mirroring on a switch. And this last option is the most common one. So when working with Wireshark, we have different kinds of filters. Capture filters that are live filters that we have to use since interfaces have limit capture capability that is lower than their actual bandwidth, and also because of hard disk and memory limitations, to enhance Wireshark performance and to focus the analysis on specific packet types. And we have display filters, which are after capture filters that display subset of the packets captured using the capture filter, and its main purpose is to focus the analysis. They are more granular in search, and there is no data loss because we do not filter packet captures as the case is with capture filters. Then we have color filters that were renamed to coloring rules that have the syntax of display filters and can be considered a modified or another type of those. And we can use existing filters of all these types that come by default with Wireshark and that can be modified, or we can create new ones that will be saved to be used later without the need to rewrite them again. So in this lecture I have given a brief introduction about Wireshark, and in the next lecture we will start our hands-on by downloading and installing it. In this lecture I will explain how to download Wireshark and install it on Windows 7. So I went to the link shown here, and then I will click on this link to download the Windows installer for Wireshark. Then I will click on Save File. So now we see that Wireshark is being downloaded. So I will stop recording and continue after the download is complete. So now we see that the download is complete, so I will click here to start the installation process. Then we click on Run, and then Next, and then I have to agree to the license agreement. And we see that here we have the options to install the previous version of Wireshark, which is version number 1, but I will not install that, so I will click on Next. And we have the options to create the shortcuts, so I will select also to install a desktop icon. Then I will click on Next, and then Next, and here we see the option to install the WinBcap, so I will click on Next. Here we see the option to install also the USB bcap, which can be used to sniff traffic from USB devices such as a USB keyboard. So here I will click on Install. So here we see that WinBcap is already installed on this machine because we have installed it when we have installed GNS3. So I will click on Cancel to preserve the installed version. Now I will click on Next, and then let us finish and start Wireshark. So here we see that we have installed Wireshark successfully, and let us go to GNS3 and try to capture traffic there using Wireshark. So here in GNS3 I clicked on this link and then select Start Capture, then click on OK. Now if I went to the router and try to ping the BBCS, we see that we have packets here. Let us search for ICMP traffic. So here we see packets of the protocol ICMP between the router and the VBCS. So in this lecture I have demonstrated how to download and install Wireshark on Windows 7 and how to capture traffic using Wireshark in GNS3. And in the next lecture we will explore the Wireshark GUI and we will work with the capture filters. In this lecture we will start exploring the Wireshark GUI and we will work with capture filters. So here we see the list of the interfaces that Wireshark can capture traffic from, and to capture traffic from an interface, for example the wireless network connection interface, I can double click on the interface or select it and then go to the capture menu and click on start, or simply click on this icon. So now we see the packets that are being captured on this interface, and I can stop the capture by clicking on this icon or button. And here we see that we have 3 panes. The first pane is the packet list pane, which contains the columns of number, time, source, destination, protocol, length, and info that gives content details. And this view of columns can be customized. And here we see the details pane, which gives information about each layer content. So we see the protocols and their fields content, and at the bottom we have the packets bytes pane, which displays the data content in hexadecimal or in binary, which Wireshark interprets in the details pane. And we can change the layout by going to the edit menu and then preferences and then layout, and we can change to the layout that we like. So this one is the default layout. So let us now start the capture again and continue without saving. And here we see that we have many of protocols in this capture. So what if we want to focus our analysis on a specific protocol and to prevent the network interface card from being overwhelmed? So we can do that by going to the capture filter field. So if, for example, if we want to capture TCP traffic, we see now that we have packets of TCP only, but no packets of UDP, for example. Another way is by going to this button, and then, for example, if I want to capture the traffic that is not TCP, so I will click now on start. Now we see that we do not have any TCP traffic. A third way is by going to the capture menu and then options, and we see that the same dialog box we have seen before was opened. And we can use existing packet filters. So for example, if I click here, we see that we have an existing capture filters that were included by default with Wireshark. So for example, if I want to display UDP only traffic, I will click here and then click on the interface. So here we see that we have traffic that is UDP only, and we do not see any TCP traffic. And here we see this protocol, the SSDB, that is UDP protocol with the port of 1900. So what if we want to capture traffic of that protocol only? We can go here. We can manage the capsule filters and edit the existing ones. So this one of UDP only, I can copy that one, and then here set the UDP port to be 1900, and then let us change this name to be SSDB, and then click on OK. And now I can find this filter added, and then I will click on the interface. So now we see packets of SSDB only, so no TCP packets and no other UDP packets are captured. The final way of working with capture filters is by going to the capture menu and then select capture filters, and this time I will create a new filter from scratch instead of modifying an existing one. So I will click here and let us capture traffic going to the IP address of Google DNS, and I will modify the name to be Google DNS, and then click on OK, and then I will select that packet filter and click on the interface. So now we do not see any packets because we do not have any traffic to or from the specified IP address. So if I tried now to ping that IP address, we see now traffic captured. So in this lecture we have explored the GUI of Wireshark and have seen multiple ways to work with the capture filters, and in the next lecture we will see how to work with display filters. In this lecture I will explain about how to work with the Wireshark display filters, but first I will add some information about how to work with capture filters that we have seen in the previous lecture. So for example, we have seen that we can use existing capture filters or add an additional one or modify an existing one, and we can also write a filter in this box and then save this filter, and using these existing filters will help us to save them and use them later without the need to write them again. And there is another benefit when working with capture filters from the capture menu and then select options, which is we can apply a different capture filter for each interface, and by choosing output we can save the capture to a permanent file, and using the options tab we can configure when to stop capturing. So let us now start explaining about the display filters. I will start capturing on the wireless connection interface. So now I will stop the capture. So if I want to focus on a specific protocol, for example IGMP, I can type that in the display filter box and then hit enter. So now we see only packets of IGMP, and we can also apply a specific value as a filter that is present in the packets. So for example, if I want to search for packets from this IP address, I can right click on it and then select apply as a filter and then select it, so that will display packets from that IP as a source. Or we can use the not selected. So for example, if I want to search for packets that are not from the source IP address, I can select not selected, and we can search for a specific field in protocol. So for example, if I want to search in TCP for a specific destination port, for example this one, I can click here and then select apply as a filter and then select it. So here we see that we have packets of SSL only, so the destination port of 443. And we see that when we apply the filter, that a display filter expression was written automatically in the display filter box. So if we want something to help us to write those expressions, we can click here, and here we see that we have many of protocols and fields and relations and the values. So for example, if I want to search for the packets that have the sign flag, I can go here and then select this one and then click on OK, and I have to delete this filter first and then click here. So now we see packets that contain only the TCP sign flag, and here in the status pane we see that we have 16 packets displayed from more than 2000 packets that are captured. And we can also use existing filters like we have seen when working with the capture filters, and we can also modify existing ones or add new ones. And we can also reach the same dialog box from the analyze menu and then display filters. And we here in this packet we see that we have name resolution for the organization part of the MAC address. So name resolution is enabled by default in Wireshark, and we can change the settings of that by going to the edit menu and then preferences and then name resolution. So we see that name resolution is enabled for MAC addresses but not for the IP addresses, and it is recommended to turn that off for hosts or IP addresses, because that can degrade the performance of Wireshark or fail to work correctly, or also will inject some traffic into a network of DNS that can interfere with your actual traffic. So in this lecture I have explained different ways of working with the Wireshark display filters, and in the next lecture I will explain about working with the coloring rules and how to save captures. In this lecture I will explain about how to work with coloring rules and how to save packet captures. So here we see that the sign packets that we have configured the display filter 4 in the previous lecture have the color of gray, and this is because if you go to the coloring rules, we see that TCP sign and fin packets have this color by default in Wireshark, and we see other coloring rules, and these coloring rules help us to distinguish specific types of packets within our captures. So what if we want to create our own, we can click here, and then for example I will search for UDP dot port 53, which is the port of DNS. So we will search for DNS packets, and then I will set the foreground to be red and the background color to be blue, and I have to enable this rule, and then I will click on OK. Then I will click here. So here we see these packets of DNS that are colorized with our coloring rule, and we know that DNS packets are UDP packets, and we see here that we have UDP packets to be with this color, but because the DNS rule is the first line, then it takes precedence. So coloring rules are working like an access list, so the first ones take precedence over the ones at the bottom. So we have to put the most specific ones first and the most general ones at the bottom. So if I moved the DNS rule here and then click OK, we see that packets belong now to the coloring rule of UDP, but if we went and disable the rule of UDP, we see that the rule we have configured is working again. And we can also colorize conversation. So for example, if I want to colorize this conversation, I can click on colorize conversation and then TCP, and I can select an existing color or create a new one. So I will call that conversation rule, and here we see that the coloring rule has the same syntax of a display filter. So now I will configure the colors, and let us select yellow and red. So now we will search for packets with this conversation, and now I will click on OK. So now we see these packets, and we can configure a display filter for conversations also. So for example, for this conversation, the same conversation, I can configure a conversation display filter. So here we see the packets that belongs to this conversation, and in Wireshark we can also ignore and ignore packets, and also we can mark and unmark packets. So for example, if I marked these two packets and then came later to compare them, so I will click here, this packet, and on the second put them side by side for comparison. And if I want to save the packet captures, I can go to the file menu and then click on save as, but that will save the whole capture, so all the packets captured. But what if I want to save specific packets? I can use the export feature, so export specific packets, and here we see that we can save the all captured packets or just the displayed ones, and we can also save selected packets, marked packets, the packets between the first and last one marked, or a specific range, and also we can remove ignored packets. And here we see that the default format of saving packet captures is the pcap-ng, which is the recommended format of saving packet captures, because it saves also the interfaces of capturing and the comments if we write any. So here in this lecture I have explained how to work with coloring rules, which is a modified or another type of display filter, and we have seen how to save or export packet captures. In this lecture I will explain about how to use the follow TCP stream feature in Wireshark to find malicious files and then extract them to be analyzed with a service like VirusTotal, for example. So here in Security Onion, if I opened the Sguil application and then I will go to the escalated events and then I will click on the alert ID and then select to pivot to Wireshark. So here in Wireshark, if I clicked on follow TCP stream, and from our analysis in Sguil, if we click on show rule, we see that we have an exe file. So in Wireshark I will search for exe, and here we see that we have this exe file. So now in Wireshark I will extract the file. So we see the file, and I will save it into the desktop, for example, and then I will open a web browser. Then I will go to VirusTotal, and then I will upload the file. Now we see that the file is being analyzed. So we see that the file is indeed malicious and is detected by most antiviruses. So in this lecture I have explained how to use the follow TCP stream feature in Wireshark to find malicious files and then extract them to be analyzed by services like VirusTotal, for example. In this lecture I will give a brief introduction about Kali Linux. So Kali Linux is an advanced penetration testing Linux distribution used for penetration testing, ethical hacking, and network security assessments. And penetration testing is the practice of safely testing a computer system, network, or web application to find vulnerabilities that an attacker could exploit. And black hat hackers use the same tools in Kali Linux, but we, as the pen testers or white hat hackers, will use them safely and with authorization from the organization we conduct testing for. So knowing how to use these tools included in Kali Linux will be very useful for us as security analysts. The terms ethical hacking and penetration testing are often used interchangeably. But ethical hacking, on the other hand, is a more general term that includes all hacking methods and other related cyber attack methods. So it requires wider knowledge and more work than pen testing, which is more focused on a specific area of interest. So the main goal here is to identify vulnerabilities, implement countermeasures, and test if that worked. And since these skills of pen testing and ethical hacking are for red team security professionals, while the CCNA CyberOps certification is a blue team security certification that focuses on security analysis and incident response rather than pen testing, then we will not take a deep look into Kali Linux and its tools. However, knowing the basics and the main ideas is very useful for you as a security analyst, so that you can understand attacks in production and simulate them in your labs. And we have hundreds of tools in Kali Linux that are organized into categories. Information gathering, where we have tools such as Multigo, Nmap, and Nmap. Vulnerability analysis, and here we have tools such as Nikto and again Nmap. Password attacks using John the Ripper, Offcrack, and other tools. Wireless attacks, which include tools such as Aircrack NG. Exploitation tools such as Armitage, Metasploit, and Sguil. And we have web application analysis, database assessment, and other categories. And in the next lecture, we will explore how to work with two tools that are very useful and very popular, Metasploit and Nmap. So in this lecture, I have given a brief introduction about Kali Linux. In this lecture, I will explain how to download and install Kali Linux. So, in the link shown here, we can select the version of Kali Linux that we want to download. And here we see different versions, including the light one, which is smaller in size and contains fewer tools than the full version. So it is suitable if you have slow internet connection, and after that you can download packages on demand. So it is a customized version that is based on your needs. And we can also go to this link shown here and then download the OVA or Open Virtual Appliance or VirtualBox, and then import it into VirtualBox so that we will not download the ISO image, configure the VM, or install the OS. But in this course, I have chosen to use the first method of all these steps. So I have already downloaded the full image. So here in VirtualBox, I will start configuring the Kali Linux VM. So I will click on New and then type the name of the machine, which is Kali Linux, and here we see that the type and the version was detected automatically. So I will click on next, and then I will set the RAM to be 2 gigabytes, and if you used 1 giga of RAM, then that will be okay also. So I will click now on next, and then I will create a new virtual hard disk, and I will select the hard disk to be VMDK, and then I will click on next, and I will leave the type of the disk to be dynamically allocated, and the recommended size of the hard disk is 20 gigabytes, but I will configure that to be 30 gigabytes, and then I will click on create. And now I will configure other settings. So I will go to network and set the network adapter mode to be bridged adapter, and then the promise case mode to be allow all, and also the storage I will insert the Kali Linux ISO image into the optical drive. So I will click here and then select this image that I have downloaded, and then I will click on OK. Now I will start the machine in order to begin the installation process. So I will select the install option, and I will select the language to be English and the country to be United States, and here I will select American English. And now we have to configure the network, so I will configure the hostname to be Kali Linux, and I will configure the domain name later. Now I have to set the root password, and then I have to confirm this password, and I will set the time zone to be Eastern. Then for the hard disk, I will select the guided use entire hard disk, and here I will hit on enter. Set all the files to be in one partition, and then I will finish partitioning. Now I will select yes. So now we see that the system is being installed. So here we see that we are being asked if we want to use network mirror. So I will select no here, and now we see that the group bootloader is being installed. Now I will click on yes to confirm the installing of the group bootloader, and here I will select the installation location for the group bootloader, and here we see that the installation is complete. So I will click on continue to finish the installation. So here we have to enter the username, which is root, and then the password of the root account. I will click on sign in, and here we see the desktop of Kali Linux. So in this lecture we have installed Kali Linux successfully, and in the next lecture we will start exploring it. In this lecture we will start exploring Kali Linux, but let us first run the machine in the skilled mode. And the first thing I want to show you that you can configure settings for the root. For example, you can log out or configure account setting for this account, and also you can go to settings to configure the settings for the system. And here we have the favorites bar that contains the most popular tools which can be customized, and we can access all of the tools by clicking here. So here we can find all the applications of Kali Linux, and we can go to the application and browse the categories. So here we have the information gathering category, and here the vulnerability analysis, and so on. And we can also browse for subcategories. So under the information gathering category we have DNS analysis, IPS identification, and other subcategories. And under the vulnerability analysis we have Cisco tools, fuzzing tools, and other subcategories also. And let us now explore some tools. So for example, MultiGo is used to gather publicly available information about a specific domain from data sources such as DNS records, whois records, search engines, online social networks, and visualize that information in a graph format. It can view relations between people, emails, groups, web pages, domains, networks, and internet infrastructure. And Nikto is an open source web server scanner which performs comprehensive tests against web servers for potentially dangerous files and programs, outdated versions, version-specific problems, server configuration issues, and will attempt to identify installed servers and software. And we have AirCrackNG, which is a complete suite of tools to assess Wi-Fi network security through packet capturing, conducting attacks, testing capabilities, and cracking Wi-Fi passwords. We can also use Scabi, which is a powerful interactive packet manipulation Python-based program. It is able to fork or decode packets of a wide number of protocols, send them on the wire, capture them, match requests and replies, and much more. So for example, you can use it for IP address spoofing, manipulating TCP flags, and traffic sniffing. So in this lecture, we have explored Kali Linux and some of its tools. And in the next lecture, we will download and install the Metasploitable VM. In this lecture, I will explain about how to download, install, configure, and explore the Metasploitable VM. So, in the links shown here, we can use one of these links to download the Metasploitable 2 VM and then import it into VirtualBox. And this VM is built from the ground up with a large amount of security vulnerabilities. It is intended to be used as a target for testing exploits with Metasploit. So here we see that I have already downloaded the Metasploitable VM in zip format that contains the hard disk of the VM in the VMDK format, and I have already extracted this virtual hard disk into some folder on my Windows machine. So here in VirtualBox, I will create a new virtual machine with the name of Metasploitable with the type of Linux and version of Ubuntu. And then I will click on next, and I will set the RAM to be 4 GB, and then I will click on next, and I will use an existing hard disk, which is this one that I have extracted from the download. So now I will click on open and then create. Now in GNS3 I will import these machine. So I will click on new and then Metasploitable and then finish, and also I will import the Kali Linux machine. Now I will drag both two machines into the GNS3 workspace, and I will start them, and then connect them to the Ether switch. Now I will configure IP addresses for both VMs. So for the Metasploitable VM, I have to enter the credentials for the login, which is MSF admin with the same password, and then I will set the IP address for Ethernet 0 interface to be 192.168.1.3 with the net mask of /24. So here in Kali Linux I will configure an IP address. So sudo if config for the Ethernet 0 interface with the IP address of 1.4 and the net mask of /24, and then I will try to test connectivity with the Metasploit VM, so the 1.3 IP address. So here we see that we have replies coming, so we have connectivity. So let us try and access the Mutilide web application on the Metasploit VM. So the 1.3 IP address and then Mutilide. So here we see the Mutilide web application, which is a free, open source, intentionally vulnerable web application that we can use for web pen testing. It is developed by the OWASP, or Open Web Application Security Project organization, which offers many resources to help developers secure their applications and to identify attacks. The OWASP publishes a report every 3 years that details the top 10 most widely exploited web application vulnerabilities during that period. So here we see the link for these top 10 vulnerabilities that we can use for testing in our labs. So in this lecture I have explained about how to download, install, configure and explore the Metasploit VM. In this lecture I will give a brief introduction about Nmap and how to work with it. So Nmap is a free and open source scanner that can be used to discover or map the hosts and surfaces on a computer network to build a map of that network. To map a network, Nmap sends specially crafted packets to the target host and then analyzes the responses. These responses deduce information about the target, including operating systems and software versions, since targets can respond differently depending on their type. For example, OS fingerprinting can be done by looking at the TCP window size and time to leave in the IP header of the first packet in a TCP session. Some Microsoft Windows operating systems have TTL value and TCP window size of 128 and 8192 respectively, while Cisco routers have TTL value of 255 and TCP window size of 4128. Linux operating systems have TTL value of 64 and most of them have TCP window size of 5840. And examples of scan types that we can use with Nmap are TCP scan using the SS option, version scan using the SV option, operating system scan using the O option, target port scan using the P option. And we can use evasion techniques to evade firewalls and intrusion detection systems. So we can adjust timing, which controls the balance between the performance and accuracy, and there are 6 timing templates that can be used. T0 or paranoid, which is very slow and used for IDS evasion. T1 or sneaky, which is quite slow and used also for IDS evasion. T2 or polite, which slows down to consume less bandwidth. It runs 10 times slower than default. T3 or normal, which is the default. It uses a dynamic timing model based on target responsiveness. T4 or aggressive, which assumes a fast and reliable network and may overwhelm targets. T5 or insane, which is very aggressive and will likely overwhelm targets or miss open ports. And we have decoy using the D option, which makes it appear to the remote host that the hosts you specify as decoys are scanning the target network too, so it hides the real attacking IP among other spoofed ones. Using too many decoys may slow your scan and can make it less accurate. In addition, some ISPs might filter out your spoofed packets, but many might not do that at all. Also, there is fragmentation using the F option to evade intrusion detection systems and packet filters by splitting up the TCP header over several packets to make it harder for them to detect what you are doing. Idle or zombie scan using the SI option, which takes advantage of an idle system by employing it to scan our target. It monitors the IP IDs of the responses and determines the port status from that. Idle scan is considered to be the ultimate stealth scan. Bad checksum using the bad sum option, which sends packets with invalid TCP, UDP, or SCTP checksum to find packet filters and intrusion detection systems. If the target responded, then it is likely one of those, unlike the case is with hosts that will drop those packets. And we have NSE or Nmap scripting engine, which is one of Nmap's most powerful and flexible features. It allows users to write and share simple scripts to automate a wide variety of networking tasks with speed and efficiency. It extends Nmap's functionality in 5 different ways: network discovery, more sophisticated version detection, vulnerability detection, backdoor detection, and vulnerability exploitation. When working with scripts, you can execute group of scripts using categories, Boolean expressions, or wildcards. And we have hundreds of scripts included with Nmap. And here are few examples: HTTP sitemap generator, MySQL dump hashes, HTTP SQL injection, and broadcast EIGRP discovery. So in this lecture, I have given a brief introduction about Nmap and how to work with it. And in the next lecture, we will see that in practice. In this lecture, we will start our hands-on practicing with Nmap. So I will open a terminal window and then I will try to use scan to the Metasploit VM. So here we see the services that was enabled on the VM, and also we see that we got the MAC address, and from the MAC address we knew that it is an Oracle VirtualBox VM. Let us now try a version scan that will give us more information about the enabled services. So here we see the versions of each service that's associated with an open port. So for example, the HTTP or web server is running Apache. Let us now try to identify the operating system using the capital O option. So here we see that the operating system is Linux. Let us try to find the OS for the router. So here we see that the router is a Cisco router that runs this iOS, and we see that the only running service on the router is the telnet service. So it is unlike the Metasploit VM that has many services running. Let us now try to run insane scan, so T5 for specific ports, so for example the HTTP and HTTPS ports. So we see that the HTTP port or protocol is running and the HTTPS is not enabled on the VM, and we see that the scan was completed in about 13 seconds. Let us use the same scan, but this time with the sneaky timing, so T1 to evade intrusion detection systems. So we see that the scan was completed in about 58 seconds, so it is more slower than the previous one. So that is why it is used to evade intrusion detection systems, because it runs slowly. And also I will use another evasion technique, so I will try to use the decoy option. So I will spoof these IP addresses, and I will go to the router and enable debugging using the command debug IP packet detail to see the spoofed packets. Now I will execute the command. So here in the router we see packets coming from the spoofed IP addresses, so the 250 and the 200. Let us now try to use scripts. So I will use the script that is the default one that will give us more and detailed information. So here we see this information like the NetBIOS name, the work group, and many other information. Let us use another script. So the HTTP site map generator script that will give us details about the sitemap. So here we see the directory structure of the website. So we have seen that scripts give us detailed information. Let us now try to work with Nmap, which is UI for Nmap. So here we see that we can select the type of the scan, and by selecting the type we see that the syntax of the command is changed, and here we can specify the host. So let us try an intense scan without ping to the Metasploitable VM. So here we see the results of the intense scan, which is uses the capital A option that is like running the default script. And here we see the services that were discovered on the machine. So in this lecture we have explored how to work with Nmap and have seen many options that can be used with it, and then we have seen how to work with Nmap, which is a GUI tool for Nmap. In this lecture I will give a brief introduction about Metasploit. So the Metasploit framework is an open source tool for developing and executing exploit code against a remote target machine. It is a sub-project of the Metasploit project, which is a computer security project that provides information about security vulnerabilities and aids in penetration testing and IDS signature development. In 2009, the framework was acquired by a company called Rapid7. The Metasploit framework is designed to be modular, so new modules can be created and integrated into the framework. When working with Metasploit, you identify systems and services using scanners, which are auxiliary modules. Then you have to take advantage of a vulnerability and allows the execution of the payload using exploit modules. Examples of these is triggering buffer overflows or bypassing authentication. After that, you have to deliver the software called a payload to the target system to provide access or to take control of it. Examples of that are starting a meterpreter session or executing some shell commands. After successful exploitation and remote connection, you can run post modules to set up keyloggers or download files, for example. And you can pivot from the exploited system to other systems. We have also encoder modules, which are programs for performing encryption. And finally, there are Nmap modules, which simply does nothing and are useful for filling the void in executables. And for the commands, we have the search command that will help you to find the module you need. Then we have the use command to select that module. We also have the info command to get all the information about the selected module, including its options and their current settings. You can view these options also using the show options command. And you can configure or change the settings of these options using the set command. The most important option to set is the rhosts option that is used to specify the target system. We have many other options also depending on the module used. Examples include ports, threads, username, password, user file, password file, database, Sguil, and so on. And finally, you execute the actions of the module using the run or exploit commands. And the Metasploit framework has tools with GUI, such as Hermitage and Community. So in this lecture, I have given a brief introduction about Metasploit and about how to work with it. And in the next lecture, we will see that in practice. In this lecture, we will start our hands-on practicing with Metasploit. So we can launch Metasploit by clicking here or from the terminal. So let us first conduct an Nmap scan for the Metasploitable VM with the version option. So here in the results we see that we have a PostgreSQL database on the Metasploitable VM with the TCP port of 5432 and with this version, and we can get the same results using the Metasploit framework. So I will launch now the Metasploit framework. So MSF console, we see that the framework is starting now. So let us search for the port scan modules, and here we see that we have a module for TCP port scan. So let us use that one. So use auxiliary scanner port scan TCP, and we can get info about that one using the info command, or use the show options command, and we can also use the set command to get the options that we have to set. So here we see that the ports are by default from 1 to 10,000, and the remote hosts parameter is not set, so I will set those using the set command. So set ports, let us configure that to be from 5,000 to 6,000 to include the port of the post degree, and I will set the R hosts to be the IP address of 1.3, which is the IP address of the Metasploit VM. Let us check for our configuration. So we see that the ports and the IP address are configured now. So now we can use the run command or the exploit command. So now we see that the port of the post degree is open. We can also get the version of the post degree database using the post degree version module, and we have to set the R hosts to be the IP address of 1.3, and then we can use the exploit command or run command. So here we see that the version was found. Let us now try to find if we can log in into the database using the login module, and then set the host, and then use the run command. We see that we have one successful login using these credentials. Let us now try to access the database using the auxiliary admin post degree, and then Sguil module, and set the remote host and the SQL statement to be, for example, select database name from the BG database, and then run. Here we see that we have error because of the R host. So if I use the set command, we see that we have to set the R host parameter but not the R host. So I will set that one and then run again, and here we see that we have three databases: the Postgres, the template 0 and template 1. And also we can use the Hermitage, which is a GUI for the Metasploit framework. So I will click here. So now I will click on connect, and then yes. So now we have to specify the IP address of the computer that will be attacked, which is the 1.3 IP address, and then I will drag that one here, and then I will search in the auxiliary for the scanners, and then Postgres, and I will try to use the login module, and here we see that the parameters are configured. So I will click now on launch. So we see that we have one successful login, which is the same login that we have discovered using the command line of the Metasploit. So in this lecture we have explored how to work with the Metasploit framework using both the command line and using the GUI of the Hermitage.